Okay, so we're going to have a look at the sine rule, and we're going to have a look at the sine rule to find the length of a side or an angle, and the sine rule works in triangles. So the sine rule is often written as sine A over A equals sine B over B equals sine C over C. Now, what does that mean? Well, it means for a triangle that has, or triangle ABC, A, B, C. So point, 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 all joined to make triangle ABC. Now, the triangle has angles at, in each of those corners of the triangle, and we're going to call the angle here angle A, capital A. So that's matched to this one. And similarly with B and C as well. So let's grab some more colours for those two. Now, the strange thing about this formula is it's got three parts. Well, why is that strange? Well, it's strange because it's the only formula of its type that has two equal signs and three bits in it. And that's because it's working where sine of A divided by corresponding opposite side A. So I'm going to do that one in green to match that pair up. B, side B is opposite angle B. There it is. I'm going to color code that one. And side C is opposite angle C over here. And we use lowercase for the sides, and we use capital letters for the angles. Now, here's the thing. I think this sine C over C is deeply unhelpful. Certainly, you don't need it. You don't need it because you're never going to substitute all three things. You're going to deal with two pairs of opposite sides and angles at a time. So let's just simplify. We're always going to be in a situation where we've got two pairs of angles and sides, and we're going to know three of those things, and we're going to use that to work out the fourth. Now, this version of the formula here, where we have the angles as the numerators, this is the version that's best for us to find an angle. And if we want to find a length, rather than change the denominator down here and make that into a numerator and go through the algebra of that process, we're not going to bother. We're just going to flip the formula the other way up. A over sine A equals B over sine B. And that really simplifies the rearrange later on when we need to do that. How is that legit? Well, it's a bit like saying that that 3/6 is the same as 1/2. Yeah, it simplifies. That's true. But the other way up, it's also true. 6 divided by 3, 2, is the same as 2 divided by 1, 2. It works. It's all fine. We can do that. We can flip both sides. It's allowed. It's okay. So let's have a look at some examples then. So in the first example, we have a triangle, and we're going to find the length. So we're going to write down the length version of the sine rule. How do we know it's the sine rule? Well, let's have a look. It says find the length of BC. Well, BC is this side here, and its opposite angle A. I'm going to give it the name lowercase a, because that's how we label things for the sine rule formula. So that's lowercase a, and just highlight these two in blue. And we've got, so this is an opposite side angle pair that we want one of them. And the other one here with angle C, 53 degrees, that's angle C, and the 5 meters, we've got that pair. So that's what's telling us it's sine rule. We're looking for two pairs of opposite sides and angles, and we know three of the things we want the fourth. So sine rule length formula. A over sine A equals B over sine B. Stop there. We're going to substitute, and very helpfully, these ones are, we're going to be substituting with 42 and A, or we're going to call it BC, then we're not going to lose sight of the fact that that's the thing we're going to work out. Let's call it BC. And sine of A is 42, so sine of 42. Now, here you have a choice. We could change, we could start chopping and changing these to relabel them as C or something, or we could just go, oh, it's the other side opposite angle pair. So this one here, that's a length, that's 5 meters, 5. Sine B, don't worry about the fact that we've got angle B up here. It doesn't matter. It just means the other one. The opposite of the length is the angle, so 53 degrees. So sine of 53 degrees. If it makes you more comfortable, you could totally change that to a C and change that to a B, and then B is 53, and we've swapped out B 53. Entirely up to you. So we're trying to make BC the subject, and we're going to do that by undoing divide by sine 42. So let's times by sine 42. Times by sine of 42, both sides. And I like to do it in this order. I'm not going to reach for the calculator to do this and get that to decimal, because I'll have to just reach for the calculator again later on. Don't want to do that, waste of time. Really, if I can, I want to reach for the calculator once, saves time. Reach for the calculator now, fraction times sine 42. Going to get length BC. The calculator tells us it's 4.18 and digits. Now I write dot 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 to show that there's more digits. I just write a load. We've been asked to give our answer to 3 significant figures. 1, 2, 3. Oh, so we're rounding to 2 decimal places. Fine. So it's 4.19 meters. Don't forget units. And that one's all done. Let's have a go at a question where we need to find an angle. So in this question, you might recognize the triangle. Yes, it's the same triangle as before, but we're just going to find angle ACB. Let's identify it first. So angle ACB is the angle you get going from A to C to B. It's this one here. That's the one we're trying to find out. And we might notice that, oh yes, these two make a pair, but we already know this pair. And that's telling us it's a sine rule question. We've got a side and opposite angle pair and a side and opposite angle pair, and we're missing one of those 4 things. So, as discussed at the start, we want the angle version of the sine rule. So the angle goes at the numerator, capital. So sine A over A equals sine B over B. Version ready to use. Let's do some substituting. A is 42. Capital A, that was. Side A is 4.19. Sine B, well, angle, the other angle, we don't know, do we? We know that side B, the other side involved, is 5 meters. But the angle opposite is called C in this question, or ACB. We don't know. That's the thing we're trying to find out. Again, you could relabel it, or you could just call it, give it its name in this question C, the thing we're trying to figure out. And then rearrange. How are we going to rearrange? We're going to times by 5. Going to undo dividing by 5. Do you have to write this down? I would. Gives you something very clear and easy to write in the calculator. Now, at this point, I would actually type it in the calculator. You could apply inverse sin minus 1, and then get a massive bracket. At this point, it's probably not worth it, because the writing time is going to take longer than typing on the calculator. So Type that in the calculator, we get 0.7984, and a load more. That makes sine C. Don't clear your calculator. We don't want to type that in. That wasted time. We've got an answer on the calculator. At this point, we're trying to aim for C. We need to apply the opposite of sin. That's the arcsine function, the sin minus 1 function. The inverse sin function. And you just type in sin minus 1. And then that gets you 52.985 stuff. Of course it does. It's that angle that we had in the previous question, which, because we want to round to two significant figures, 1, 2, try that again, 1, 2, that makes 53 degrees. 53 degrees. That's C, and that's how you find an angle with the sine rule.